Hey, this is Anthony, co-founder at ReductStore, and in this video we want to see the following thing. So I have a block diagram here. So basically we want to record images, right, from the robot and with a camera driver, and then we have some ROS2 node which publish topics, and in each topic you have the image, and so each image is associated with a timestamp and some labels. Labels can be from inference of an AI model, or in that case it can be a tag or a numerical value. In this example we have numerical value between 0 and 1. And so how do we store those images with labels and a timestamp in a database? In our example we use ReductStore, so a time series object storage solution, and then we set up a replication task to replicate certain images to another instance on a central server. But it can be also to the cloud, or in this example I use my laptop and I have a remote device for the robot. We want to use here ReductStore because of we need fast ingestion, and also we need to make sure we don't overrun the disk, so we will use a FIFO quota based on volume that we can control with ReductStore. And we want to index the images with a timestamp, so we need a time series solution, right? And then based on labels we have a replication task which will replicate only the pictures with label greater than 0.5. Then when the replicated pictures are on the remote instance, or in this case my laptop, we can access those data with query language or HTTP API. And we also could, if we happen to have this instance in the cloud, we could let me show you that. We could connect this instance with a bucket, so it could store blob data in a blob storage, so to reduce costs by a lot compared to other time series databases like Timescale or InfluxDB. You could lower the cost by like 10 times for record like images that are maybe 100 kilobytes or so, and we do that with a Fuse driver. We will not cover that in this video, but just so you know that there is this possibility as well. So let's start with two things. So first we need to set up the ReductStore instances. For that we have documentation, so ReductStore documentation, get started. Easiest is to use Docker and to tell the path where we want to store the data, right? And we need to do the same as a central server, so we need two instances in this example. For me, I have a remote device on my local network and my laptop. This is the IP address of my laptop. And once you run those instances of ReductStore, you can access the web console. So this is the remote device, and I have created a bucket called ROS2 images where I want to store ROS images, right? You can set here the FIFO quota. So based on volume, I set it to 200 gigabytes. So this is a quota where when you have more than 200 gigabytes of images, it will start removing all the pictures. And then inside images, you can see that, okay, I can download my image, and it's associated with a label. In this example, value between 0 and 1. You could also query those pictures based on the label. For example, so we have this query language, which, for example, if I want images greater than 10, 0.5, let's say, I would write it like that, and something. Here we go. So I give the label with an end, and then the operator with $sign, and I can tell the value that I want. I can fetch the record, for example, here only with labels greater than 0.7. See that can also be used, and we will use this exact query for replication tasks later on. And so that is on the remote device, and then I have one instance on my laptop. I call the bucket laptop for sake of the example. In that case, in the bucket, I don't have any quota, and that's fine. Often on a central storage, you don't need any quota for the bucket, and I don't create any entry myself. It will be created by the replication task because I want to replicate all the entries from this bucket to the central storage, right? So those are the two instances here. And now let's see what we need in terms of ROS2 node. So I have the code here. So first of all, let me zoom in a little bit. So I should have images. So yes, I'm on my remote device here, connected with SSH, and you can see that I can see some image topics, and I want to subscribe to those topics and to store them in time series object storage with a simple node which listen to the image topic. In case here I want to store the compressed image, so I have this compressed image type to initialize the buckets. So this, if it exists, so I mean if it's also okay. If it doesn't exist, we'll create it here with a quota size, another quota size data set. And so it's standard ROS node, ROS2 node, where you can set the topics you subscribe to. And then what is interesting is how you store the data, right? So here, first thing you need to do is that you need to serialize your message, because in ReductStore you can store any binary, but you need to have those bytes, right? So binary data needs to be in byte, and for that I serialize. There are many different ways. You could serialize here. It was for the sake of the example, but we're not using that. But this is a method from ROS, right? Where you can serialize your image. Then it will be in this format in the database. So when you query it, you have to make sure that you use the deserialize method from ROS. Otherwise, you can't read it. It's still a good option, because what is important is that the way you serialize is cross-platform, so that you can deserialize. If you are on Windows, Mac, Linux, it doesn't matter. You should be able to deserialize that message. And in our example, we know that the compressed image is JPEG. So we just take the content of the message in a byte stream, that we store directly in ReductStore, right? So the way we store the data is that we have to give the entry name, the data itself, which is bytes, timestamp in microseconds, and then the labels. In that case, the labels is just a random value between 0 and 1 for the example. The content type needs also to be given. In that case, it's a JPEG image, right? So if we run this node, it should subscribe to the image, it receives the image and store that image with the random label. So quite simple example, right? If we go back into our remote instance, the ROS2 image is here. So we can see the amount of data is just increasing, right? 400, 456, quite fast. That's not a problem. It's made for it. So what is interesting now is that we can, if we see on my laptop, central storage, there is no data, right? But you can set a replication task. So to give you the context, so you set the replication task here on the robot, and it will push the data to the central storage. I will give you this example. So you create here replication. I call it to laptop. And I want to replicate images from the ROS2 images bucket to the laptop bucket. The host is available. I tried it before. It was this one. So the one I have here, right? This is the IP address of my laptop on my local network. I do use token authentication, so I can't log in right on my laptop. So I need to set an API token. So for this instance, I set it to ReductStore. And then what I will do is I need to give the token here as well. And you could replicate, for example, one image every nth or every s seconds. In our case, we just want to have a condition that I copied before, so it's the same language. So here we want to, let's say we want to replicate only critical images, can call them like that way, when let's say it's greater than 0.9, the label random value will create the replication task, and now the replication task is active, there is no error, and we can check on the laptop bucket how many records are replicated, and 19 records. If we refresh, of course it will increase, and here all the labels are greater than 0.9, right? So let's see, a bit more records can query, and they are all greater than that. So we can easily set replication tasks, right? You could also set replication task between buckets, and that would work as well. And it can be based on any label. And so the setup is pretty easy, right? So to store in ReductStore, the best practice is to make sure we have good serialization of the image. So either it's open format like JPEG, PNG, or we use serialization method from ROS, and we use the same deserialization method when we query the data. And then we have to be careful about the FIFO quota that we set on the robots to never run out of space, and make sure we set that boundaries for the amount of storage we use. And the replication task can be used as part of your reduction strategy. If you want to store a subset of images to a central storage or to the cloud. And once you have data in the cloud, you can also set up a fuse driver with a blob storage to reduce the costs of cloud infrastructure. I hope this was useful. See you in the next one.